Good afternoon, learner. Myself, Professor N.D. Mehta, Assistant Professor, Power Electronics Engineering Department, Vishwakarma Government Engineering College, Chankheda. Today, we are going to learn about USB, Universal Serial Bus. The learning outcome of today's session, learners will be able to understand terms related to USB, describe the working of USB, develop bus organization for USB, and application of USB in the different system.
Welcome to the basics of USB for the first-time developer session. USB is very easy from the user's perspective. You just plug your device in and it works. From the developer's perspective though, USB can be very difficult, but Silicon Labs makes developing with USB easy. This session will discuss the basic terms and concepts about USB that you should be aware of when developing your system. The ultimate goal is to arm you with the important information you need to make the right decision about your products. Finally, we'll discuss some resources available to help you along the way. Let's first go over some of the basic terms. The first is USB, which stands for Universal Serial Bus. A host is the master of the USB system. The host coordinates and initiates all of the traffic on the bus. The peripheral is the slave of the system and communicates with the host only when the host has an outstanding transaction. OTG stands for on the go and has limited host capability. A hub is an expander of the host ports. In addition, a hub acts as a repeater in that it increases the distance a device can be away from the host. A frame is the time division of the USB bus. The frame is the basis of all USB communication. A packet is a bundle of data for transmission. A frame is made up of multiple packets. Enumeration is the handshaking process that occurs whenever a device is connected to a host. The little sound in Windows indicates the start of the enumeration process, and the device appearing in the device manager with a success message indicates successful enumeration. Finally, a descriptor is a structure in the device firmware that describes all the capabilities of the device, what interfaces it supports, what type of device it is, etc. The bus consists of a host and the host's root hub. Devices then connect to the host through the root hub. A hub expands the number of devices the host can connect to. The host is the coordinator of all traffic, so transfers are discussed relative to the host. Therefore, an in transfer is moving from the device to the host, and an out transfer is moving from the host to the device. Speed devices are devices that operate at 1.5 megabits per second. This is supported by Silicon Labs devices, but generally not recommended for use, as it's slower than full speed. Full speed is 12 megabits per second and is supported by all Silicon Labs devices. High speed, or 480 megabits per second, is not supported by Silicon Labs devices. The bus speed determines all the USB frame timings. There are three main transfer types: bulk, interrupt, and isochronous. Bulk is a high data throughput transfer type with guaranteed delivery, but does not have a guaranteed latency. Examples of this transfer type are mass storage, WinUSB, libUSB, and the Communications Device Class, or CDC. The interrupt transfer type is a low data throughput transfer with a guaranteed latency. Interrupt devices get one 64-byte packet per frame, and examples of this are the Human Interface Device, or HID, like a mouse or a keyboard. Finally, the isochronous type provides a guaranteed latency and a high data throughput, but does not guarantee delivery. This type is intended for audio or video applications, where missing a packet of data here and there doesn't cause any issues. As previously mentioned, the frame consists of multiple packets and provides data structure for the bus. The first part of the frame is the start of frame, or SOF. Then the rest of the frame consists of the control and data packets. Frames are continuously occurring, and with a full-speed device, each frame is 1 millisecond in duration. For example, if we had a bus with two interrupt devices and two bulk devices, the frame might look like this: a start of frame, two packets for the interrupt devices, then a control packet, packets for one of the bulk devices, and packets for the other bulk device. It's important to note that if the device isn't ready when the host attempts to communicate with it, the device can lose its slot or slots in that frame. There are two types of certification for USB devices. USB logo certification refers to hardware. Any device that features the certified logo has undergone hardware USB testing. The USB.org website is the official USB organization and has testing houses available for hardware certification. Drivers can also be certified, and this process is different for different operating systems. Silicon Labs has an application note to guide our customers through certification for Windows. Based on the information we've covered, here are a few things to keep in mind as you're planning or creating your USB-enabled application. It's important to know that USB is a serial interface, and as with any serial interface, timing might be quite different from the interface it's replacing. For example, UART is generally a steady stream of information, and replacing this interface with USB using a CP21X device may change the timing of the data, although the data will all be delivered. Another thing to note is that every device shares the bus with all the other devices. If there's a large number of bulk or isochronous devices on a single bus, this may limit the throughput of each device. Finally, it's important to note that if an interrupt device misses its slot because it's not ready to communicate with the host, it may have to wait another millisecond before it gets another turn. There are lots of USB resources available. Silicon Labs offers many examples and drivers to make USB development easy. If you get stuck, visit our knowledge base for troubleshooting tips. If you want to dive deep into the protocol, we highly recommend Jan Axelson's USB Complete for detailed USB developer information. Silicon Labs offers full-speed USB peripherals and on-the-go devices. We make USB development easy with a wide range of examples and drivers for any application. Go to our website and find the device that works for you. Thank you for listening.
Is there any questions regarding the USB? So students will be able to discuss the questions into the forum. Thank you very much to enjoy this lecture, and hope you soon meeting with the another topic next time. Thank you very much.